Hello, today I'd like to talk about peak detectors. So right now we're looking at three different ways to measure AC voltage. Right over here on the oscilloscope you're seeing what actually comes out of your outlet, which is a sine wave. And when we measure this, we're measuring the RMS value on these three displays. So what exactly are we measuring? Well, we have a sine wave. So at the power company we have a power generator that's going in a circle, but we want to get this circle down to our outlets where we can do something with. But if it's a circle, it's just going to go in one place. But if we take this circle and take the first half and then the second half, and then we keep repeating this is how we get the sine wave. So we basically take a circle, move it down the wire so we can have our circle over here to drive motors or run other different things. But when we take different measurements on this, so this signal is actually alternating from 0 to some peak value, going back to 0, going to a negative peak value, and coming to 0. So what we're measuring here is the RMS, and what the RMS is about 0.707 up from the top, and on a AC sine wave we measure 120 volts or thereabouts, and this is RMS. Now why we use RMS is if I took this signal and applied it across a resistor and then took a 120 volt battery and put this against the same resistor, it would heat it up to exactly the same temperature. So that's why we call this a true RMS, or the heating value of a particular signal. So what we're measuring is the RMS value, but there's times when we might want to look at a different value. So some meters have the ability to measure peak. If I put this meter into the fast peak mode, it measures 161 volts AC. So what we're doing there is we're measuring this peak value. So on 121 volts, actually this is not 121 volts. I'm going to put it back into, this is 117. So on a 117 volt signal, what we're going to be measuring is 161 volts peak. So this is measuring the peak. Now this meter here also has a peak value mode, which I enact by putting in this, and it goes into a peak min max mode, but all it shows is now 119. It doesn't really give us a much higher value. The reason is this has a very slow peak mode, this has a very high fast peak mode. And the difference is this one, the red meter, has a 30 millisecond, and the other meter has a 250 millisecond in which it can capture it. So if we take our sine wave that's going in a circle, this is 60 hertz, or 60 times a second. Well, to find equals cycles per second. Now let's say we want to determine how long is this from one cycle to this, how many seconds is that? Well, if we go 1 over this value, we will turn this into seconds per cycle. So if we go 1 over 60, what we get is 1,666, but because this is in milliseconds, it's 0.0166 repeating of a second. Now this meter over here is 30 milliseconds. 30 milliseconds trying to capture 16 milliseconds, it's just not fast enough. Where this other meter that measures 250 microseconds, that's about this much, so it's able to capture this peak mode. So when you're looking at a meter that has a peak detector, you're going to want it to be significantly less than 16 milliseconds, and the Fluke 87 has 250 microseconds. So 250 microseconds is 0.250 milliseconds is 0.000250 seconds. So you can see it chops this into tiny little, and that's why this peak detector is kind of important, because we can also see here when I enact the peak detector, it immediately captures 160, and here we're at about 160. So that's actually pretty good. I've also set the cursors. So what we're seeing here is on this, this is the 0 point, this is the top. So between these two cursors, we're measuring 160 volts peak. So that's how we would measure peak on a sine wave. A nice thing about a meter that has a relative mode is we can take this 160, if we hit the min-max, now we're doing a negative peak, which is minus 159 or about 160. So now we're looking down at this value here, and this is about 160 volts minus. So we have 161 to 160. By using relative mode, I changed this to be the 0 point. So now we're measuring from the bottom of this waveform all the way to the top of this waveform to get a peak-to-peak measurement, which I can see is 322 volts. So by having a fast peak detect, we can take a lot of different measurements that we would normally have to have an oscilloscope with. It's handy to just have a meter that can be able to do that, but your meter has to have a fast enough peak detect in order to do that on an AC sine wave. So this is very handy for troubleshooting power quality problems, just seeing if you have a clipping on the top of the waveform, because you can have a lot of different types of waveform problems. If you're having power problems, what can happen is instead of a nice clean sine wave like this, you might have a situation where the sine wave is being clipped at the top for some reason, and it's going like this. This is also what you see when you start to get voltage sags. So with a voltage sag, instead of having a good, let's say 120 volts and 163 volts peak, what you might end up with is more of like a sag, and here you're getting your RMS is going down to maybe 105 volts RMS, and your peak might be going down to like 140 volts or so. I'm not doing the math exact, but this is how you can measure if you're having some power quality problems. Another thing that can happen is if you have harmonics. What harmonics do is they actually kind of cut the sine wave into pieces, and how you get this is anything that has energy efficiency. This is how they get it to use less power. They cut the waveform. By doing this, what happens is the ratio of the RMS to the peak is no longer the same. So the RMS is a 0.707 of the peak, and the peak equals about 1.6 something of the RMS. This ratio will be messed up when you have a signal like this. So by being able to take these peak versus RMS measurements, you can see if you have a nice clean sine wave, if you have a clipped sine wave, if you're having a sag, or if you're having harmonics problems. So this can be a very handy feature to do this type of work with a meter instead of having to go to an oscilloscope or a power analyzer to actually see it. What you're probably going to do is use your meter to detect it and then go to a power analyzer to analyze exactly what's going on. Or maybe just an oscilloscope like this, something simple. So it's not that difficult. It's very easy to use, and this is a handy use of the peak detector inside of a multimeter as long as it's fast enough.